Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about the Zener Diode and its VI characteristic. First, let us understand what exactly we mean by Zener Diode and what is the difference between PN junction diode and Zener Diode. A Zener diode is a PN junction semiconductor device designed to operate in the reverse breakdown region. In normal PN junction diode, we know that we always use PN junction diode in forward biased condition. When we apply forward voltage to the PN junction diode and when we increase the voltage beyond a knee level, then the diode starts its conduction. Voltage across the diode become constant and current increase. This characteristic of forward biasing is similar in case of Zener diode also. In case of PN junction diode, when we apply reverse voltage, the only leakage current flow. When we go on increasing the voltage in a reversed bias condition, at certain point avalanche breakdown happen and very high current start flowing through the diode, and in this condition mostly diode will be damaged. But there is a difference between Zener diode and PN junction diode. A Zener diode is a PN junction semiconductor device designed to operate specifically in the reverse breakdown region. The breakdown voltage of a Zener diode is carefully set by controlling the doping level during manufacturing. Even though the current through the diode changes, the voltage across the Zener diode remain constant during reverse breakdown condition. This is called the Zener effect. Now let us see the symbol of the Zener diode. It is almost similar to the PN junction diode. It has also two terminals, one terminal that is anode and another terminal that is known as a cathode. Normally we use a Zener diode in a reversed bias condition. The meaning is cathode is made more positive compared to anode. Now let us see what exactly the difference between avalanche breakdown and Zener breakdown. We will study about the Zener breakdown. When reverse biased voltage is applied to a Zener diode, it allows only a small amount of leakage current until the voltage is less than Zener voltage. When reverse biased voltage applied to Zener diode reaches Zener voltage, it starts allowing a large amount of electric current. At this point, a small increase in reverse voltage will rapidly increases the electric current. Because of this sudden rise in electric current, breakdown occurs and that is called Zener breakdown. However, Zener diode exhibits a controlled breakdown that does damage the device. Because of this controlled breakdown, current is limited by the series resistance, and in reversed bias condition, Zener diode is never damaged. VI characteristic: relationship between applied voltage V and current I passing through it, that is known as a VI characteristic. Now let us see the VI characteristic of Zener diode. On the x-axis, we apply the voltage, so forward voltage as well as reverse voltage. On the y-axis, that is the current axis, so we have forward current and a reverse current. So normally we use first quadrant and third quadrant for VI characteristic of the diode or Zener diode. When we apply voltage in the forward direction, or when Zener diode is forward biased, the characteristic is almost similar to the PN junction diode. We have knee level voltage, and when we increase the voltage beyond a knee level, then sudden increase in the current is observed. But we never use Zener diode in forward biased condition. We always use PN junction diode for this purpose. We use Zener diode in a reverse biased condition. So when we apply reverse biased voltage, only the leakage current will start flowing through the cathode to anode. But at certain voltage, that is known as a breakdown voltage, that is known as a Zener voltage, Zener breakdown happen, and with slight increase in the reverse voltage, current will start flowing. Now voltage remain constant, and this property of constant voltage we use for Zener diode. The Zener breakdown voltage of the Zener diode depends on the amount of doping applied. So we can have a controlled breakdown. We can plan controlled breakdown for different voltages. If the diode is heavily doped, Zener breakdown occurs at a low reverse voltage. On the other hand, if the diode is lightly doped, the Zener breakdown occurs at a high reverse voltage. Zener diodes are available with Zener voltage in the range of 1.8 volt to 200 volt. Specification: Zener voltage or Zener breakdown voltage. The Zener or the reverse breakdown voltage range from 2.4 volt to 200 volt. This range varies between manufacturer to manufacturer. Current IZ maximum. It is the maximum current at the rated Zener voltage. So voltage remain a rated voltage. The maximum current that may be in the range of 200 microampere to 200 ampere. Current IZ minimum. It is the minimum value of current required for the diode to break down. Once the reverse current reach to minimum value, then and then possible breakdown happen. Power rating. It denotes the maximum power the Zener diode can dissipate. It is given by the product of the voltage of the diode and the current flowing through it. Temperature stability. Diodes around 5 volt have the best stability. Voltage tolerance. It is typically plus minus 5%. Zener resistance. It is a resistance to the Zener diode exhibits. Now let us see the application of the Zener diode. It is normally used as a voltage regulator. Zener diodes are used as a reference voltage device. Zener diodes are used in switching operation with transistor. Zener diodes are used in clipping and clamping circuits. Zener diodes are used in various protection circuits. But we will study application of Zener diode as a voltage regulator. From the rectifier, we have output voltage, but output voltage change with the input AC supply variation. So we use Zener diode to get constant output DC voltage. So this application is very important, and in the next lecture we will see application of Zener diode as a voltage regulator. Advantage of using Zener diode. Power dissipation capacity is very high. High accuracy, small size, low cost. So this is all about Zener diode and its reverse biased characteristic, and why the constant voltage across the Zener diode is available during reverse biased condition, that is explained in the lecture. So thank you for watching my video. Keep watching. Thank you very much.